In this section, we'll talk about security essentials and best practices on AWS. We'll do a little overview of cloud security concepts, the shared responsibility model, and talk a little bit about AWS's Identity and Access Management Service. AWS security. What are the perceptions of cloud security? What do you think is cloud security? What does that mean to you? And I'll kind of leave that open for people to post on the chat to see if we have any comments on what your perceptions of cloud security are. Anyone? What do you think it means when AWS says that the AWS cloud is secure? Or what are your expectations? All right. They're constantly evolving their security practices to keep up with modern threats. So that is correct. It's something that's constantly happening, right? Your resources are secure, your files are secure. Yes, that's part of it. There's more, and we'll dive into this. Right. So at AWS, cloud security is job zero. It's the most important part of providing a public cloud service, right? All customers benefit from a data center and network architecture that is built to satisfy the most security sensitive requirements for top level organizations, such as government organizations, right? Public healthcare organizations, etc. Some of the big accreditations and certifications that AWS holds are, some of them are listed on the screen. There's a lot more, and you can look at that URL for a full list. But things like SOC 3, PCI compliance, FedRAMP, HIPAA compliance, etc. You can run all those security compliant workloads on AWS. And a lot of companies are already doing so right now. I mentioned the shared responsibility model. What is the shared responsibility model? It's basically a contract between you, the AWS user, and AWS that basically defines what things you are responsible for and what things AWS is responsible as far as security goes. Right? AWS is responsible for security around facilities, the physical security of those facilities, the infrastructure security, security on those storage devices, the network devices, the virtualization layer, and we'll dig a little deeper into some of these concepts in a minute, right? And AWS is responsible for providing you some identity and access management capabilities that are secure in themselves. On your side, as a customer, as a user of the AWS public cloud, you are responsible for your application, your network configuration security, right? If you leave a security group that's open to the world, it is your responsibility to make sure that that is intentional, that it's not a security group that's being used for a private data, a database, right? That is open to the world. So network configuration, security groups, operating system firewalls, just the operating system itself, you are running your own machine, your own virtual machine. So you are responsible for the operating system on that machine. Security around your applications. You have to make sure that your applications are secure, that there is proper authentication and authorization methods in your application. That is your responsibility. It's not AWS's responsibility. You're also responsible for the account management, the management of your AWS account, the policies that you enforce or don't enforce on your AWS account, right? AWS gives you that flexibility to determine how secure you want to make your account or your resources on AWS. And if you put those two together, you put the security responsibilities from AWS plus your responsibilities together, then you can start to achieve some of these security, like not badges, but some of these goals, right? If you want to make your application HIPAA compliant or SOC 3 compliant, then it's a combination of relying on the security responsibilities from AWS and implementing your own security responsibilities. Right. So understanding who is responsible for what is critical to ensuring that your AWS data and systems are secure. This is a different breakdown or different look of the shared responsibility model. Right, as I mentioned before, AWS is responsible for the global infrastructure, for the security around the availability zones, the regions, those data centers, the edge locations, right? The physical security of those locations and the hardware that is stored in those locations where your virtual machines run. Things like compute storage, database, and networking, the physical components of that, of the foundation of those AWS services. And you as a customer are responsible for your content, your platform, your applications, how you manage your security for your account and your users, security around operating systems, right? Network and firewall configuration of both your operating systems and the services that AWS provides, such as security groups, NACLs, WAF configurations, etc. Security around your data, whether you decide AWS gives you the ability to encrypt the data at rest, or whether you decide to do that or not. So it's client-side data encryption and server-side data encryption. And also protection of your network traffic, those NACL rules, right? How do you protect your traffic using those security rules or security groups? So all of that is your responsibility as a customer of AWS. Other things that AWS is responsible for, as I mentioned earlier, are physical security of the data centers, right? They've been building large data centers for many years, and they take security very, very seriously, right? Because they have to comply with the security requirements of these large organizations and large government entities that have really high requirements for security. Right, so they have nondescript facilities. There's robust perimeter controls around those. There's very highly control of who has access to these facilities. There's always two or more levels of two-factor authentication to get into these actual physical facilities. Right, so, and all access is logged and reviewed. There is a very strict separation of duties within employees to determine who has privileges to what areas. So all of that is stuff that you don't have to worry about. Also, AWS is responsible for the security around AWS instances or the underlying infrastructure that runs those AWS instances, right? The host or the hypervisor running those operating systems. The individual SSH keys that you get when you create new instances. And again, all access is logged. Also, the EC2 instances, the operating systems, and the underlying infrastructure, and those stateful firewalls, the physical firewalls on AWS, because the ones that you are familiar with, or the ones that you use, such as security groups, are virtual firewalls, right? But there are actual physical firewalls, and AWS is responsible for the security of those devices. And then things around network security, around IP spoofing, packet sniffing, and scanning of those ports, etc. AWS continuously monitors traffic into those. All right. Other things that AWS is responsible for are configuration management. Configuration management of things like to make sure that you have the ability to understand what is going on with AWS security changes that are happening with their AWS data centers, such as when there's an outage, right? There's a health dashboard that allows you to see when there's an outage at a specific data center, or when one of the services is not functioning properly. Right? They also are responsible to make sure that things are built for continuous availability, that things scale and are fault tolerant, that your availability zone are always on, right? And that's why there is multiple availability zones across every region to make sure that if something were to happen, there's still a backup. And to make sure that there is always a robust internet connectivity across all of the AWS services, regions, and availability zones. They're also responsible for disk management, making sure that they have processes in place to wipe out and discard disks when they're no longer being needed, or to wipe them out before a new customer comes on board. Right? And they follow the very rigid process to make sure that all storage devices are destroyed properly. All right, so this is a bit of an exercise of what things are a customer's responsibility versus what things are AWS's responsibility. And I'm just going to slowly go through these. So configuring the security group rules that determine which ports are open on an EC2 Linux instance. So is that a responsibility, an AWS responsibility, or is that a responsibility of the customer? Based on the shared security model, this would be a responsibility on the customer, right? Because you are responsible for managing those security group rules. Preventing packet sniffing at the hypervisor level. We talked about how AWS is responsible for that hypervisor level, the level that lies beneath your virtual machines. So in this case, AWS would have that responsibility to make sure that that is protected. Patching the operating system with the latest security patches. This is referring to the operating system on your EC2 instance. So in this case, you are responsible for making sure that your operating system, whether it's a Windows or Linux server, is patched with the latest security patches. Shredding disk drives before they leave a data center. Well, there's no way we can have access to those disk drives to shred them. So that would be AWS's responsibility. Securing the internal network inside the AWS data center. Again, AWS is responsible for all the physical security of those data centers. Installing camera systems to monitor the physical data centers. Again, same thing, that's their responsibility. Toggling on the server-side encryption feature for S3 buckets. So S3 buckets, or S3 gives you the ability to encrypt data at rest, right, with a server-side encryption feature. And that would be your responsibility. Right? AWS provides the S3 service, and is responsible for the underlying infrastructure. But in this case, you are responsible for making sure that your data is encrypted. All right, so this is the orange ones are AWS's responsibility, and the blue ones are your responsibility. All right, and I'll pass it on to Chris to talk a little bit about identity and access management.
Cool. So I'm going to be talking about some of the services that AWS provides to allow you to secure your infrastructure kind of on a management level. So the first service I'm going to talk about is identity and access management, which is let's get into kind of understanding where that plays in your security toolbox. So identity management is the management of individual principals with their authentication, their authorization, and what privilege levels they have to your resources. The thought here is that we want to increase security, but also maintain a level of productivity with that. So we cover the 3 A's. Authenticate, kind of saying, hey, I am who I say I am. Authorize, okay, because of this is who I am, this is what I'm authorized to do. This is the level of permissions that I have to interact with services. And then audit, which AWS has a service called CloudTrail, which can log all the API calls against it, so that you can have a trail of saying, okay, I know at this time, this person ran this API call against this service and made this change. So it's a great way to understand and audit and be able to go back and understand what occurred at a given point in time in your infrastructure, which, as opposed to a traditional data center, you might have cameras or you might have access logs, but besides that, you don't really have a comprehensive audit log unless you maintain one. But again, that's up to people to create tickets or log what they're doing in a run book. Now, because AWS is a platform, it's infrastructure as a service, and to manage services on top of that, we need to understand the layers of security and what types of layers of authorization need to occur. So again, AWS is a platform where you run infrastructure and manage services, but you also have virtual instances. So like in the case of you running an application on an EC2 instance, to interact with that EC2 instance at the AWS level, to spin it up, to spin it down, potentially to attach it to a load balancer, that would be all done within the realm of AWS identities. But you might have a level or access to your operating system. And that would be your Linux passwords, your key management services to interact with your SSH keys or your Windows logins on the operating level. And then you have your application. So what end users potentially interact with if they're logging into, say, a Netflix account or their SAP account. It's not the operating system access, it's what's on the application. So we definitely want to differentiate how those are managed and understand that AWS doesn't take care of all of those for you. There's still layers of authentication that do need to occur. Now, they do provide services that allow you to provide those as part of your application or managing your operating system, but definitely delineate and being aware that it's not the end all be all to all those things unless you configure it to be that. So with AWS, we want to understand who, what would we consider a principal. So the primary principal would be the account owner, and that's the user account that's tied to creating the account, billing, and then has access to the console and API and access to customer support. We'll talk about some best practices with that root account later. But then we have the idea of IAM users, and that they too have access to the console, the APIs, and the like, and specific resources, but they'll have policies associated with them. The other type of principal is temporary security credentials, that you can create temporary access to various services across the AWS platform to say, hey, here's a one-time usage to access this S3 bucket, or I will give you access temporarily for 15 minutes to interact with this DynamoDB table or the like, or this IoT call, etc. And those can be all set up through APIs or the SDKs to programmatically temporarily grant access. It's a great way to give automated tasks or programs or servers access to do things on your behalf, but not with a permanent entrenched configuration on those devices or instances. Cool. So authentication, how do we use it? How do we use it? So we use it to log in. So you've already used IAM in a way to log into your account. So going to the console, you provide the account, either account ID or the key associated with your account. For that, your username, your password. You also have the ability to do multi-factor authentication or providing a security token with your access to that. And then with API access, you can create access keys and access secret keys. And those, a combination of those two are what you use to grant access to the API level within your code base, something like that. So a way to, again, grant access to automated tasks. So we recommend, AWS recommends with that root account that you definitely want to create an MFA device, add a second level of authentication to it, so that instead of just logging in with the password, you also have to provide a token to get into it, because that is the account that potentially could shut down your account or have the largest blast radius associated with the account because it has access to do all. And then just like you would do for an operating system, don't use the root account. Create IAM users for specific levels of access. And we'll be talking about that a little bit more later, but there's a methodology that you can create policies and assign those to users or groups of users based on different thresholds of access that you'd like them to have. And then again, really hitting this home, the root account has unrestricted access to all resources. Your IAM might have a level of access that gives more permission, and then the temporary ones typically are set up for a specific resource. So like, hey, this code can only interact with a specific AWS S3 bucket. But as you can see, you want to make sure that you have least access privilege for your accounts and make it as granular as possible. And AWS gives you the tooling to do that. And just if you're familiar with any user management system, you can create hierarchies and groups of access and create different groupings and share that authorization at a group level versus have to individually manage the access there. AWS also has a managed Active Directory service. So it's one of the means that you can use to provide operating system access to your Windows boxes. There's Microsoft AD, which is the managed service that gives you Active Directory. It's running on Windows 2012 R2, and it can create a trust relationship with your on-premise AD configuration as well. Simple AD is, say, if you don't necessarily need to create a trust relationship, but you just need a quick, easy Active Directory configuration, you can set that up. Or if you're wanting to make sure that your Active Directory is set up to use your on-premise Active Directory, there's an active AD connector service as well. And one of the cool things about IAM that we don't get into too much here, but just want to bring up, is that IAM also supports this idea of federation, where you can use an existing user service that is SAML compliant, so like Okta or Active Directories are two that come to my mind right off the bat. And then you can federate your IAM users to interact with groupings that are configured there and create a SAML trust relationship with those accounts that you already have set up. The next security topic we'll talk about here is encryption. So question for you guys, and maybe you want to put it in there. You just want to maybe answer for as if you were working at a different company versus your own company. How are you currently encrypting your data? What are some of the practices? What are some of the methodologies that you're using for encryption with your existing environments? And I'll just look at chat right now to see if there's anything, or the Q&A. A lot of times when I do this, you know, in person, people will say, hey, we're not encrypting any of our data. Or if I'm talking to a bank, we're saying we're encrypting everything. Sometimes there isn't a lot of middle ground with companies there, but AWS gives you a lot of great tools to encrypt your data. And so let's talk about some of those now. So kind of when we're talking about encryption, there's encryption in transit. So when you're moving your data between places or different instances or different services, how are you doing that? So definitely want to make sure that you're encrypting your data in transit, but you're also encrypting your data at rest. So most people typically just think about encryption at rest. You know, am I encrypting my data at the operating system layer or on the disk layer, and the like, but you want to make sure you're doing both to secure your data there. So there are definitely a lot of services that we can support that. In terms of encryption at rest, AWS supports EBS encryption, so those elastic blocks storage that you attach to your EC2 instances it can be set up there. There's file system tools that can be used. And then AWS Marketplace, which we haven't talked too much about, but it's a place where you can use third-party solutions and incorporate those. So some of them provide software or AMIs that you can launch in your data center, and you get kind of the AWS pricing model associated with them. So only paying for what you use that solution for with a hourly rate associated with the software. So a lot of AMIs are out there that provide security encryption tooling to encrypt your root volumes, etc. We talked about S3 yesterday, so object level encryption. S3 has a lot of them. So there's server-side encryption. You can do server-side encryption with keys that you provide, or you can encrypt the data yourself before you put it into the S3 bucket. A lot of different options there. Database RDS has encryption for MS SQL, MySQL, Postgres, and Oracle. RDS offers. RDS, we'll talk more about later, is the managed relational database service. And then Redshift, which is a data warehouse service, also has encryption capabilities with it. A great managed service that I love using to manage SSL TLS certificates is the AWS Certificate Manager. So instead of having to go out and procure SSL certificates from a third party, you can use a certificate management to create and deploy and renew the certificates, and you can attach them to your CloudFront CDN distributions, your Elastic load balancers, and it's all managed and configured as part of they're integrated with those services. It also allows you to create your own if you need a private certificate. The ones that are associated with CloudFront and your Elastic load balancers are free, and there's a cost associated with creating a private certificate. There's also AWS Key Management Service, which manages keys. So if you need keys for encryption, it allows you to create a master key, or I like to call primary keys these days, and then create sub keys based off of that key, and then have specific keys for individual services and the like. So great thing about KMS is it's integrated directly with these services. So you can just go ahead and say, hey, allocate me a key, and grab one off of the KMS without having to go through the procurement process and then importing it, etc. But sometimes there are times when you might have regulatory requirements that you need to use your own key. And so some customers have hardware security modules or devices in their data centers that they use to manage their keys. And then AWS has a CloudHSM. So if you need to generate your own keys and make sure that you're managing them and controlling them, you can do that. AWS manages the appliance in terms of it being in the data center, but then you're controlling your keys and are the only ones that have access to those keys. And then you can be compliant with higher regulatory needs. And just in all case purposes, the CloudHSM uses the SafeNet Luna device. So if you're familiar with that, it's that exact device, but it's just available to you in the cloud. So now we're going to be talking about some tools that kind of help you along with your security management, managing all the different components and giving you visibility into your security profile. First one is Amazon Inspector. It basically gives you a vulnerability assessment. So it can look at your environment and look for vulnerabilities that exist and give you a report based off of if it's finding malicious activity within your environment. And it's a great thing just to turn up and have it look at your environment to get a good profile of potential vulnerabilities that might occur over time. AWS WAF, Oscar mentioned it earlier in terms of blacklisting. This is a managed service that can integrate with a lot of different endpoints. So it can integrate at the global level with like CloudFront distributions, that worldwide content distribution network. You can create rules that look for SQL injection, cross-site scripting. It can do geo-based blocking. So if you need to block a country because of things, or only, you can do the reverse, only allow content from a specific region. Some great things you can do there, and you can create rules or use managed rules and tie that to your application. And then on the local or the regional level, it can integrate with your elastic load balancers and protect those resources as well. I mentioned CloudTrail earlier. This kind of gives you a little bit more detail into the granularity of what it provides. It tells you what API call, who made it, and what the parameters associated with that call are. So if you need to go back and say, hey, you know, Ted from network made this configuration change, he made it at 2 o'clock, it's like you can point a finger at Ted to say, hey, Ted, why did you do that? Or, you know, you understand what changes occurred where. It's a really powerful tool to go back and view actual changes in your environments. CloudWatch has a lot of different services. So CloudWatch is kind of your central place for monitoring. So AWS services provide metrics that feed into CloudWatch, and then you can create alarming based off of. You can also, CloudWatch also has a logging capability, so you can pipe logs into CloudWatch and do trending based off of that, and you know, review your logs. Typically, I see a lot of people creating metrics like for certain thresholds, like if my CPU of my web servers are above a certain threshold, notify me. But you can also say, hey, if the threshold of my web servers are above a certain threshold, launch a new one or launch 10 more to cover that difference. So it integrates with things like auto scaling and load balancing to help you manage your fleet. So since this is all API driven, you can create events based off of occurrences and really automate your backend or your configuration, make it more software defined and adaptable versus saying, hey, page me in the middle of the night, I have to manually intervene. You can automate a lot of that responsiveness. Cool. VPC Flow Logs. So we just dealt with VPC. And so if I had flow logs enabled for the VPC, we could potentially have seen all those ping requests that were getting rejected. So it gives you that granular log of occurrences, exceptions that might have occurred because of a configuration change. So either malicious or confirming that your configurations are working, or maybe helping you troubleshoot what's going on and giving you a little bit more detail of what that would look like. It's going to give you your account. It's going to give you the interface, a source, destination, IP address, the protocol, the number of packets, the bytes, and whether or not it was accepted or rejected. So a lot of granular logs there. So with that, let's get into some best practices. What, how do we put this all together? Like, this might be overwhelming, like there's so much going on. But here are some things that are recommended that you do as AWS customer. I love AWS Trusted Advisors. It's something when I'm managing environments that I look on at a daily basis. So I'd recommend customers looking at it at a regular interval, like set up a Monday morning meeting reminder to check your Trusted Advisor alert to kind of just review everything that's going on. It has a security, so it's basically using the pillars of the well-architected framework and gives you recommendations of how you can improve your environment. At the base level, it gives you a certain threshold of checks, and if you have a higher support level, it adds a lot more checks that you can look into. But at the base level, you're going to get some great security checks of like looking for security groups that might be open to the world. It gives you some cost optimization reports as well. This is the security module, so let's focus on the security here. It's a great place to check to see what's going on. Here is best practices with your EC2 instance is using what we'll be going to in a little bit, a concept of an IAM role. So we talked about different principles, and IAM has a concept of a role, which is kind of creating a relationship with the policy and the service. So with EC2, you could assign it a role saying, okay, this EC2 instance has the ability to do this, which would be something like, this EC2 instance can read from this S3 bucket, or this EC2 instance can write to this other EC2 instance. So you could read data from one bucket and you can write data to another bucket. Instead of having to put that into your code and that get potentially exposed through your code being in a repo or something like that, or exposed to your users or your developers, you just put that in your EC2 instance role. And then knowing that if you run that code there, it has the capabilities to interact with these other services. Very powerful concept there. The other one is just, understanding all the different tools working in conjunction, that you're going to use your security groups, you're going to use a web application firewall, use your encryption and trust, you're going to set up least access privileges in your IAMs. You're going to provide operating system and application management to do package management. And then, AWS is going to take care of the physical and underlying cloud infrastructure for you. Putting those all together really gives you a very great security profile that you can use to be confident in your configurations. And then here are some information and some links to learn more. The Security Center is a great place to learn about best practices, get security bulletins, how to go about doing vulnerability and penetration testing. You need to make sure that if you do need to go through some sort of penetration test, or you're working with a provider of those types of services or running yourselves, you need to get those approved beforehand. Or if you need to report an issue, make sure you report an issue through the Security Center so that they're aware of the likes of going on there. There's also a security blog and a security resources that kind of groups together all the different security packages and best practices and gives you some tutorials and white papers to look at. I love the security blog. It kind of just kind of goes deep into a lot of current day issues and provides a lot of cool solutions to how to implement security in your infrastructure. And then here's a list of compliances certifications that AWS has gone through or continually to go. These are all continuing processes. It's kind of like painting the Golden Gate Bridge, where you, as soon as you're finished, you have to start the compliance all over again. So, you know, you have your SOC compliances, your HIPAA, FISMA, ITAR, ISOs, PCI, FedRAMP. The important thing here is that if you are looking for one of these compliances, AWS takes care of the infrastructure component of it in terms of their resources and data centers. You still need to go through your specific application and your specific configuration with auditors to achieve these, but it's great just being able to hand them the AWS certification to take care of all the physical and underlying components of that process. It speeds up it a lot versus saying that it's running in your building, into your data center that might, you know, not be compliant and having to go through that audit process.